This is Geometry, Chapter 15, Lesson 7. We are on page 662, ladies and gentlemen. Now we're talking about spheres. Spheres. Okay, there's interesting facts about all of these shapes. And a sphere has the most different formula, all right? If it doesn't have an apex, then we have polygonal planes that intersect, right? Like it's a rectangular prism. If we have an apex, then it's either a pyramid or a cone. And when I say pyramid and a cone, you're thinking 1/3 the volume. Are you thinking that yet, people? 1/3, all right. Cylinder is just like any other prism. It's area of base times height or altitude. A sphere is different. Does a sphere have a base? So, does it have a lateral face? It's so different, isn't it? It's just one area. It only has volume and surface area. A sphere only has volume and surface area. It doesn't have a lateral surface area. Yeah, we're going to go over that right this minute. All right? So, the volume of a sphere. Of a sphere. It equals, you ready? It equals the volume of two cones with the same radius. The volume of one sphere equals the volume of two cones with the same radius. Now that wasn't true with the pyramid or a cone and a cylinder and a cube, right? 3 pyramids go in a cube, 3 cones go in a cylinder, but only 2 cones go in a sphere in terms of volume. In my class next year, you'll be able to see that visually. The earth is not flat.
This is it's a picture from above. Picture from above. Dude, they just use the fish eye. I think it's just a circle.
You think it's just a circle?
It's a flat circle, yeah.
It's a flat square.
It's two circles.
It's a triangle, guys.
Okay. All right, so look, I have 2 cones and I have 1 sphere on the board. Okay, I want us to think about this. How can this be? Okay, we're going to assume that they're at the same height. All right, they're the same height because that would matter for this. All right, so you know that all radii are equal. So what is the height of the sphere or the height of this cone?
2R.
2R, that is correct. So we have a radii here, we have a radii there, right? Such that the height of this cone would be 2R. You got that? Because it's the same height as the sphere. All right, now, let's recall what's the volume of a cone? It's 1/3 area of the base, pi r squared times the height.
Is the height of a cone always 2R?
No.
Okay. So just whenever
we're comparing
And
it
we
to a
know that-
sphere,
And we know that the radius is the same.
it has to be. Yeah, right. All right. I wrote 1/2, not 1/3. 1/3. All right. If I add both of these, I will get the formula for the volume of a sphere. But instead of writing H, I'm going to substitute 2r in for H because we know the height is 2 radii, right? Because of the sphere. Are you with me on that? So for H, I'm going to substitute in 2r. All right, this is algebra, guys. All right, we're going to multiply our constants. 2 times a third. You see that? You see what I'm about to do? We're going to multiply 2 times a third. So that we get 2/3 pi. What's going to be my exponent? It's going to be r cubed because it's r squared times r, and multiplication is addition to the exponents. Multiplied variables, you add the exponents. Multiplied variables, add the exponents. Again, do the same thing here. It'd be 2/3 pi r cubed. Do we have like cubed? Thank you. I said cubed and only squared it. Do we have like terms?
Yes.
We do. What can we? So what do we add when we have like terms?
Be 2.
What do we add? Huh? The fractions. And what are these called?
Oh, it's the coefficient.
Coefficients, yes. What's 2/3 and 2/3? 4/3. And this is the formula for the volume of a sphere. Any sphere. Volume, 4/3 pi r cubed. Why do you think we have 3's in here? How many dimensions is volume? 3. In every volume formula, there's always something cubed. So when we have the cylinder, let's go back. What's the volume of a cylinder? Area of the base, which is pi r squared times the... All right, if we look at those variables, this is a 3rd degree term. You add their exponents. It's 2 and 1. It's a 3rd degree term. Always, when you have volume, you're going to have something cubed. If it's a rectangle, what is it? If it's a rectangular base, it's width times base times, or width times length, maybe width times length times height. That's a 3rd degree term. All the variables, you add the exponents. 1, 2, 3. It's a 3rd degree term. Always when you have volume, you have an exponent of 3. A term that is a 3rd degree term. With spheres, it's obvious. R is cubed. You have 2 3's in volume. It's 4/3 pi r cubed. Okay. That's volume. That's volume. The surface area of a sphere is equal to this. 4 circles that have the same radii. It's as though that nobody can demonstrate. It's as though all the area, we could just place 4 circles on it, and that would be the surface area of a sphere. So, if my radius is r, then what would be the area of the circle? If my pi r squared. If my radius is r, the area of the circle would be pi r squared.
4 pi r squared.
So the surface area of a sphere is 4 pi r squared. It's 4 circles. Yes.
Okay, I don't really get how it would be 4 circles. Because it's like, if you put a circle and you put 4 of them together, it's still going to have those holes or the circles don't meet. So how would it be a sphere?
It is. There's no good video. I looked for videos to show you. There are no good videos.
So how do you prove? So
Okay, well now, I probably could work a proof to prove it, but then that would probably take the rest of the class.
yeah,
It is. Was it hard to believe that 3 of these fit in here?
Yes.
That to me was hard to believe.
Wait, what?
That oh, it was so hard for me to believe that 3 of these would fit in. And I do this every year. And I ask myself, is this really gonna work? Like, it's really gonna work. And it really does work.
Well, I want to see.
We did
You
it
can
last
do it.
class.
You can do it towards the end of the class. It is. You can fill those 3 up with water, and it will fill that cube up.
You know, it did.
And they did it, and Luke did. It's so cool. But it is. So the surface area of a sphere is the same area as if we had 4 circles. All right. So these are formulas you need to memorize. It's easier to memorize. Okay. So let's just look at some cues. They both have a what in them? What number? They both have what number? 4. Okay, that's a key. They both have a 4 in them. Surface area is how many dimensions? 2. So your R is squared. Volume is how many dimensions?
3.
But you have 2 3s here. So the cube one, you have 2 3s. I don't know if that'll help you memorize it, but that's what helps me memorize it. I know how many dimensions, and I know that volume is 4/3 pi r cubed. I know surface area is 2 dimensions, so the surface area is 4 pi r squared. All right, look at the definition of a sphere on page 662. A sphere is the set of all points in space, not on a plane, right? Because these are 3-dimensional objects that are a given distance from a given point. So what is it saying? From the very center of it, it's all these points that lie in every direction, all equidistant from that one point. Does that make sense? Very similar to the definition of a circle. All right.